Hi, this is Arpan Gupta, and today I will discuss about machine learning techniques. We will begin with what kind of data we handle in machine learning. So basically, we have two types of data, which is labeled data and unlabeled data. So we will first discuss about the example of what is labeled data. So if you see that there are four columns in this data, which is first column is time of sending email, and second is subject of email. Third is text in email body, and the fourth is email spam or not. So in this kind of problem, we want to predict something like fourth column, which is email spam or not. So we want to predict whether a given email is a spam or not based on these three columns. So first and second and third, just time of sending email, subject of email, and text in email body. Such kind of data is known as labeled data because for each of the observation, say this first row, this is at 12 a.m. this time of sending an email is 12 a.m. and the subject of email was to one price, and the text inside the email body was written like something, you have one prize to get, please call or email. So this is first three column. You see time, and you see the subject of email, and you see the text. Based on these three values, you need to predict this fourth column, which is a spam. So machine learning model is going to learn the classification whether the given email is a spam or not based on these past labels. So when you have the past labels like email, whether a given email is a spam or not, so this is called the label data. What is an example of unlabeled data? Is same thing, but we don't have the fourth column. We know that the time of sending an email is 12 a.m. We also know that the subject of email is one prize, and we know the text in the email body is this, you have one prize to get, please call or email, something like these. Say I have just shown three rows, but you can have more than 100, or you can have millions of rows as well. But you see that the fourth column is missing, and you can have n number of columns as well. So there is no limitations on the number of columns, there is no limitations on the number of rows. Only thing is, what you want to predict is not available in unlabeled data. So say this data is given, and you want to know that there are certain emails which are anomalous in the sense that it is not being sent by a genuine user, it is just sent as a spam. So we don't have in this data the labels which is telling that in the past these emails with these features are being sent, and these are spam, and these are not spam. So this is not given. In that case, we need to follow different kinds of techniques, which we will discuss later. Now the ML techniques for the label data. When we have the label data, we can use two techniques. There are other as well, but these are the most important, which are frequently used. So first one is regression, and the second one is classification. So in regression, what you do is, when you want to predict something which is continuous, in that case we will be using regression. Classification will be used when you want to predict some categories or classes. Categories may be 2 or 3 or 4. In regression, the continuous values can be many. So say you want to predict the house price. So you want to predict the house price, and on basis of the number of rooms, area of floor, location of house. That means you have been given the number of rooms, area of floor, and the location of house, and you need to predict the house price. Such kind of problem will be known as a regression problem, and in this the past data is also available. Past data, we mean to say that we know the past prices of the houses given the number of rooms, area of floor, and location of house. So this is also a label data, we can say, where we have the prices, past prices. Now say we want to predict some age of certain thing. So age can also be in number of years, it is also continuous, it is not having a category. Now let's discuss about classification. So classification will be used when you need to predict some categories. Like for an example, you want to predict whether a given email is a spam or not. So email can be either a spam or it can not be a spam. So it is either 0 or 1. So it doesn't have continuous values like 1, 2, 3, 4, 5, 6. That's why it is a classification. It has two classes, which is spam or not a spam. That's why it is called classification problem. Second example is you want to predict whether a loan application will be approved or not. Again, the loan application can be approved or it cannot be approved. So it has again two classes, and you have the past data. So given the past data, you want to learn some model which can easily predict whether a loan application will be approved in future or not. But the past data is being given. Now you want to predict whether a given customer of a certain company will churn or not, means whether the customer will come back or not, in other words. So this is again a classification problem. So either the problem will be a regression or it can be a classification problem. In classification you will be having classes like this, and in regression you will be predicting some continuous values like house prices, sale value, revenue, age, or there are a number of things which you can predict, but it will have number of values, continuous values. So I hope this discrimination between these two techniques is very clear, and this will be used, these two techniques will be used when you have the past data with labels. With labels, we mean to say that we want to predict whether a given email is a spam or not. We must have these labels in the past. We must have the data with this column, which says that this given row is a spam or not. If it is not given, then you need to follow certain techniques which I will discuss. Now, what are the common regression techniques which are being used? So this is linear regression, polynomial regression, ridge regression, and lasso regression. These regression techniques are being used for doing regression. Different kinds of problems are there. So for different problems, you use different kind of regression techniques. There are a lot of the regression techniques which you can use. So it depends on the problem in hand and the data in hand. What are the classification techniques? The basic classification algorithms are decision tree, random forest, gradient boosting. Logistic regression is also a classification technique, but it name you have the regression in it, but it doesn't mean that it is a regression technique, but it is a classification technique. So decision tree, random forest, gradient boosting, these and there are a lot others. So there are hundreds of classification techniques you can use for different kinds of problems and different kinds of data. So this was about when you have the labeled data and you have the past data, where you can use the regression and classification techniques. So this is just a this is for beginners who doesn't know anything about machine learning, and they want to know that what is regression, what is classification, and when you use regression or classification, and what are the common techniques for regression and classification. Now, when you have the unlabeled data, in that case, what you need to do is, you don't have any past labels, then you need to understand from what domain this data is coming. It can be from the banking domain, it can be IoT domain, it can be of network domain, it can be of any domain. So for that case, you need to understand the domain, what domain it is. Say if it is from banking domain, you have to understand what are the customers and how the bank wants to use that data to understand the business problem. So you need to understand the domain, and then you cannot straightforward use the techniques like regression or classification, because you don't have the columns, appropriate columns for doing any analysis further. And also regression and classification not at all possible, because we need the past data for that. So what is possible for the unlabeled data? The only possibility is to understand domain and do some kind of data exploration to understand what it is saying, and then start performing some statistical techniques using the measures, Euclidean measures, distance measures, and use some kind of grouping and clustering of data to understand if we have some kind of groupings in the data or not. One kind of problem which is usually done is anomaly detection. It is one example of task which is done when unlabeled data is given. One cannot use regression or classification, as I have already told, and also the data like we have in IoT time series data, or we have the in network in cybersecurity, or we in any other domain like this where we have the time series data, we can create it like a labeled data, but it is not actually a labeled data when you want to predict like an anomalous, whether a given thing is anomalous or not. For an example, when I said this unlabeled data email, so here we have the time, but we are not interested in time, we are interested in whether an email is anomalous or not. That means whether an email is a spam or not. In that case, we don't have, in this case which is the unlabeled data, we don't have the fourth column which is telling in the past whether a given is a spam or not. For that case, we need to understand the domain, what kind of emails we have, how frequently it is being sent, at what time it is being sent, because anomalous things happen at anomalous time, at anomalous behavior is there. So you need to find the normal patterns and normal behavior for a given domain. For this, you can count the number of words, unique words, you can count the number of uh, different words which are important for a general communication. So there are also like frequencies, and you can also check how recently a given email is being sent by a given sender. So all these features you need to create out of this, and then you have to understand if there is any kind of statistical technique you can use, and how far it is from the normal behavior. So all these kind of more or less, it is like in a statistical approach you have to do. You have to analyze a lot before you can actually use some kind of high level machine learning technique. So I hope it is clear. Very so anomaly detection is actually, first it is for time series, and another thing is like anomalous behavior detection. So in anomalous behavior detection, you have to find the features and you have to understand it, and then you can say that a given observation with these features is far away from the normal pattern, and therefore you say that this is the chances that this observation will be an anomalous. I hope it is clear to you what is possible with the labeled data and what is not possible from the unlabeled data, what you can do with the unlabeled data and what you can do with the labeled data. For labeled data, you can use regression and classification techniques, you can do some analysis. For unlabeled data, you have to of course understand the domain, and you have to do the lot of data exploration, you have to create meaningful features, you have to then use the statistical techniques to understand the distance measures, and then see that if there is any uh, patterns, normal patterns, and if there is any deviations of certain observations from those normal patterns. So these things you have to do. This is very important for the unlabeled data. So I hope it is clear. If it is if you have any type of questions, you can just uh, comment, and you can also look for other videos on my YouTube channel, Arpan Gupta. So thanks for watching this video. Bye bye.